Let's see what happens if we take a line and translate it, or slide it. You can see that we have two lines now, the one that's in its original position and the second one that's slided. What do we notice about the two lines? Well, we notice that the two lines never intersect, which means that they are parallel. Parallel lines are a pair of lines that don't intersect. See, no matter how close I put them together, they never intersect. So, if we want to make two parallel lines intersect, we need to apply rotation to one of them. After the rotation, now we have intersection points. You can think of a line as having two characteristics. The first one is the intercept of the line, and the second one is the slope of the line. Suppose that this line has a slope of 0 and an intercept of 0. To change its intercept, I just need to translate the line up for increased intercept and down for decreased intercept. So right now I'm increasing its intercept, and right now I'm decreasing its intercept. Now it has negative intercept, here it has 0 intercept, and here it has positive intercept. And now let's see what change of slope means. This line changed its slope because it rotated a little bit. The line changes slope essentially means the line rotates, and when it rotates, it changes the angle it makes with other lines. For example, see how small this angle is? Now I'm going to make it larger by changing the slope of this line, or in other words, by rotating it. Do you notice how this angle increased? The important thing to remember here is that the slope of a line, or rotation of a line, is connected to the angle this line makes with other stationary lines. While, on the other hand, translation of the line, or changing its intercept, doesn't have to do with changing the angle this line makes with other lines, as you can see here. No matter how much I translate this line, the angle it makes with the other lines is the same. Similarly, if I start translating the other line, the angles it makes with the other two lines would essentially stay the same. In other words, rotation changes angles, translation doesn't. If there is no rotation and just translation, then the angles stay the same. If there is rotation, then the angles change. Now we understand intuitively that this line is just this line but translated. Therefore, the angle it makes here with this line must be the same that the angle this line makes here with this line, because translation doesn't change angles. And because this angle equals this angle, it must be true that this angle equals this angle. Now let's try to prove this statement. I'm going to perform a 180 degrees rotation of the construction we have. Of course, if we take a line and we rotate it by 180 degrees, then it wouldn't change its slope. This line stayed at its place. This line went to this line, and this line went to this line after the rotation. And now do you see how angles x and y overlap? Overlapping angles must be equal, and therefore x equals y. And now that we have this, we get that this angle equals this angle equals x, and this angle equals this angle equals x. And this angle, this angle, this angle, and this angle must equal 180 minus x. So this is the full picture we get. Here is the optional problem. Suppose we have a pair of parallel lines here, and another pair of parallel lines here. And suppose this angle is x and this angle is y. We need to prove that x equals y. And here's the solution. We know that this is parallel to this, and this is a line that crosses the two parallel lines. And so if this angle is x, then this angle is x, this angle is x, and this angle is also x. And now let's consider this line parallel to this line. If this angle is x, it follows that this angle is x, and this angle is also x, and therefore x equals y.